Assalamualaikum and greetings to our lecturer, Madam Marina Sauki. We are from Group 3. My name is Putri Balkish and my teammate is Fatih Natasha, Amir Amzar, and Nurul Farhana. Today we are going to do presentation about the virtual assessment lab 3. So in order to understand more of the basis of this experimental setup, I will be explaining about the formulation used in order to achieve the desired mud density. So first of all is 9 ppg. Here we can see that the density for barite, bentonite, and water will be constant, where the barite will be 37.4 at 5 lbm per gallon, bentonite will be 12.07 at 5 lbm per gallon, and water will be 8.33 lbm per gallon. The density will be the constant volume, while the mass will be changed. First of all, the barite will be 0.058 lbm, bentonite will be 0.054 lbm, water will be 0.7664 lbm. Here the total of the mass will be 0.8784, while for the volume, the barite will be 0.015 gallon, bentonite will be 0.0045 gallon, and water will be 0.092 gallon, where the total volume will be 0.098. When the mud density is 9 ppg, the barite will be 26.5 gram and bentonite will be 24.5 gram. Next, for the 9.5 ppg, again the density will be constant, but for the mass, barite will be 0.129 lbm, bentonite will be 0.054 lbm, water will be 0.7664 lbm. Here the total mass will be 0.9494 lbm. For the volume, the barite will be 0.034 gallon, bentonite will be 0.045 gallon, water will be 0.092 gallon. Here the total will be 0.0999 gallon. So when the mud density is 9.5 ppg, the barite will be 58.5 gram and the bentonite will be 24.5 gram. Next, in order to achieve 10 ppg, again the density is constant. The mass for barite will be 0.1951 lbm, bentonite will be 0.054 lbm, water will be 0.7664 lbm. The total mixture will be 1.0155 lbm. The volume of barite will be 0.052 per gallon, bentonite will be 0.045 gallon, water will be 0.092 gallon. The total volume will be 0.1017. So when the mud density is 10 ppg, the barite will be 88.5 gram, bentonite will be 34.5 gram. Next, for the 10.5 ppg, the mass of barite will be 0.2679 lbm, bentonite will be 0.054 lbm, water will be 0.7664 lbm. The total mass will be 1.0883 lbm. Again, the density is constant. The volume for barite will be 0.071 gallon, bentonite will be 0.045 gallon, water will be 0.092 gallon. The total volume will be 0.1036. So if the mud density is 10.5 ppg, barite will be 1 to 1.5 gram, the bentonite will be 24.5 gram. Next, in order to achieve 11 ppg, the mass of barite will be 0.3406 lbm, bentonite will be 0.054 lbm, water will be 0.7664 lbm. The total mass will be 1.161 lbm. The volume of barite will be 0.091 gallon, bentonite will be 0.0045 gallon, and water will be 0.092 gallon. In total, the volume of mixture will be 0.1056 gallon. When the mud density is 11, The barite will be 154.5 gram and the bentonite will be 24.5 gram. So in summary, we can see that the bentonite will be constant with 24.5 gram, and when the mud density increases, the barite will also be increases. So when the mud density is 9 ppg, barite will be 26.5 gram. When the mud density is 9.5 ppg, the barite will be 58.5 gram. And when the mud density is 10 ppg, barite will be 88 gram. When the mud density is 10.5 ppg, the barite will be 1 to 1.5 gram. And lastly, when it's 11 ppg, the barite will be 154.5 gram, with the bentonite mass will be constant of 24.5 gram. Next, I will pass it to Pati Natasha.
My name is Pate Natasha Bintu Muhammad Amri, and I will explain on the principle understanding the basis of the experimental setup. The theory behind the experiment is fluid loss control is an act to control the volume of the filtrate, where it will be going through a medium which is a filter. To manage the fluid loss in the mud, it could be achieved by adding some fluid loss control material into the mud system, which are barite and bentonite. Viscosity will be used as an aid for the mud to suspend the rock cuttings, where it will be carried up to the surface. Viscosity, also known as a thickening agent, which increase the performance and quality of the mud. It is described as a material that increase the viscosity of water, oil, and synthetic drilling fluids. There are various types of viscous fire, such as clay-based viscous fire and polymer viscous fire. In clay-based viscous fire, the common type of viscous fire used in the oil and gas industries are bentonite, and it is widely used in water and oil-based drilling fluid. For polymer viscous fire, it is commonly used in water-based mud. Wetting agent is used to modify the density of wellbore fluid, and it will apply the hydrostatic pressure on the formation. It is also used to avoid any pressure spikes or pressure drops, and also preventing a blowout during the drilling process. Wetting agent also prevent any leakage of fluid into the formation that reach from the wellbore. It is also known that it is contain a high specific gravity. This is because it will increase the density of the drilling fluid. And the most commonly used of wetting agent is barite, because barite is mostly used due to its grade factor, which does not require any other factor that could lead to other problems such as pH, solubility, and more. That's all from me, and I will pass to Putri. Thank you.
Thank you, Pati Natasha. Next, listed here is our apparatus that is used to perform this experiment. First of all is cornstarch, which is used as the artificial bentonite that was chosen to be our mud viscosifier. Next is tamarind seed, which is used as a replacement to our artificial barite. Then, to change our tamarind seed into a powdery form, we use a blender as an automated grinder. Next is weighing scale that is used to measure the weight for both of those or for both of the media. And then in order to formulate a water-based mud, 350 milliliter constant volume of water was used. And then empty water bottle will be used as a beaker. Then measuring cup was used to calculate the volume of fluid and also collected the final fluid from this experiment. And then here we can also see a electrical hand mixer, which is used to mix all the tamarind seed powder, cornstarch, and water. And then lastly, hollow pipe, which is used to verify the viscosity of the solution. Next, this is the process flow diagram for our experiment. Firstly, the food waste that has been chosen are tamarind, seed, and cornstarch. We are then measured 350 milliliter of tap water by using a measuring cup that will act as the basis to formulate the water-based mud. After we measured the required amount of water, place them into an electrical foam mixture. Next, weigh about 24.5 grams of cornstarch, which is our bentonite, and by using a weighing scale and add into the 350 milliliter of water that has been measured inside the mixer. After that, plug in the power source and turn on the electrical home mixer. Make sure to mix them evenly. After a few minutes, verify the viscosity of the solution by running it into a hollow pipe and comparing it to the flow merely water into the pipe. Next, after confirming the viscosity of the solution, put the solution back into the electrical mixer, which is then we're going to put some amount of dried tamarind seed and grind them into the grinder, which is the blender that has been provided to make it into a powdery form. Next, weigh about 26.5 grams of barite, which is the tamarind powder, by using a weighing scale to increase the mud weight to 9 ppg. With the added amount of tamarind seed, we will add it into the solution inside the mixer. Make sure that to mix it evenly. After that, when the solution is completely mixed, pour the complete solution into a measuring cup to measure the current volume. Next, place the complete solution into the weighing scale to measure the mass, and then the mud density can be calculated by dividing the total mass and total volume of the solution. Lastly, record the raw data being used for the water, artificial barite, and artificial bentonite. Next, we pass into the next presenter.
Next, I will explain about the relevancy of choosing the food waste itself. In this lab, our group chose powder tamarind seed and cornstarch to replace the artificial barite and bentonite. 5 different mud formulations have been carried out to achieve 5 different types of mud density, which are 9 ppg, 9.5 ppg, 10 ppg, 10.5 ppg, and 11 ppg. Therefore, based on the graph that has been plotted, we can observe the higher the mud density needed to be achieved, the more the quantity of tamarind seed powder will be used with a constant amount of cornstarch and also water. According to Fatah and Lashin, our group set the quantity of cornstarch and water in this experiment to 24.5 gram and 350 ml respectively. The performance of drilling fluid is primarily governed by 3 major factors, which are drilling fluid density, drilling fluid viscosity, and mud pH. This is because aqueous liquid samples were prepared for this experiment. Next, to produce the drilling fluid samples, 1 gram of material is added to a 350 ml laboratory barrel, which is comparable to putting 1 pound of material to 1 barrel of fluid. More consideration should be given to these parameters when producing water-based fluid samples for experimental work. Next, tamarind seed powder has been chosen to replace the industrial artificial barite is due to the specific gravity of the food waste itself. The specific gravity of powdered tamarind seed, based on our group research, is around 4.5. Meanwhile, for the cornstarch is around 1.45. The increment of tamarind seed weight required, although in the same amount of cornstarch weight. Using the specific gravity value, we can simply compute the density of the food waste by multiplying the value with the density of water, which is approximately around 1.33 pound per gallon. Thus, we get the density of powdered tamarind seed around 37.485 pound per gallon, while density for cornstarch is roughly around 12.079 pound per gallon. Next, I will explain about the validation on experimental results with other findings. So in this experiment, we also recalculate the mud theoretically in order to validate the experimental results. There will be some differences happen due to some parallax error that might exist while conducting the experiment. So based on the graph that has been shown above, it shows the differences in percentage between the calculated and also the theoretical value. So the differences value are 0.18%, 0.59%, 1.05%, 1.22%, and 1.59%. What we can say that the maximum desired mud weight that can only be achieved is around 8.8, 8.9, 9, 9.3, and also 9.4 ppg. Due to, in contrast to the experiment conducted by Fatah and Lashin, we use the same amount of bentonite, which is 24.5 gram, that act as a viscosifier and filtering control material, whereas Fatah and Lashin has added some other chemicals, which are 0.2 gram of caustic soda, some starch filtration, hardness, rheology, control material with weight 0.4, 0.25, and 1 gram, and also about 305 gram of calcium carbonate. Next, 5 samples of drilling fluid has been created in this lab, and powdered tamarind seed that we add and act as a barite is gradually increases to enhance the mud density. In conclusion, the amount of powdered tamarind seed that we supplied in this experiment varies between 26.5 gram until 154.5 gram. Besides that, according to N.A. Ghazali alias Muhammad and Nur Suhana on 2015, they said the use of cornstarch to replace the artificial barite is very successful. This is because, based on our research, starch consists of 4 advantages. Firstly, it is high in biodegradability, because to eat grades in biodegradability is thought to have a significant potential as a mud addition for drilling wells with low bottom hole temperature. Next, starch also lack of environmental effect. Starch is commonly known as a natural polymer that exists naturally and are ready for use after minor processing. Starch is the second most abundant biomass, or also known as a renewable energy sources that found in the nature. Third, starch also ease of supply. It forms a colloid particles and has the capacity to compress and flex to fill the holes in the filter cake, reducing the possibility for the fluid loss. Lastly, starch also low in cost. Starch is a less costly natural resources as compared to polyionic cellulose, PAC, and hydroxyl ethyl cellulose, HEC. Next, to Ikram, Jan, Siddiq, and Kenanakis on 2001, they also had an investigation on the use of tamarind seed powder as an alternative ingredient in drilling fluid, especially to replace the artificial barite. So adding tamarind seed powder and combining it with a bentonite will enhance the density of the mud sample. The higher the concentration of tamarind seed powder, the mud sample will become thicker and denser. So the mud density of the samples was found to be in a range of 8.22 until 8.97 ppg in the range, which has been regarded appropriate for use as an addition in the formulation of drilling.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ami Hamza. So for my part, I will explain about the application into the real drilling operation and how can drilling industry use these additive for maintaining wellbore stability. So first point is, in drilling operation, these two additives are commonly being used to formulate the drilling fluids. According to Ikram Jansidek and Kenanakis 2021, the mud density or weight is an important property of drilling fluids in drilling industry that functions to improve wellbore stability and maintain formation pressure. Next, according to Das and Chatterjee, also, um, low mud density can lead to shear failure of rocks, known as borehole breakout, which subsequently collapse the wellbore. However, Ebikapaye reported the possible loss of circulation, decrease in rate of penetration, and formation damage um, due to excessive mud density values. Thus, researchers have worked to develop a reliable route. For example, the PSO ANN model to estimate the most suitable density of drilling fluids under high pressure and high temperature wellbore conditions. Um, it has been long desired to increase the density of wellbore fluids, and not surprisingly, a variety of methods exist. One of the method is by adding dissolved salt such as sodium chloride, sodium sodium chloride, calcium chloride, and calcium bromide in the form of aqueous brine to wellbore fluids. So another method is by adding inert, which is high density particulates um, to wellbore fluids to form a, a suspension of increased density. This inert high density particulates often referred as a weighting agent and typically include powdered minerals of barite, calcite, or hematite. And also, increase in density also result in increasing the penetration rate. However, um, when the density is excessive, it can cause differential sticking of drill string. And next is barite is chemically inert and insoluble with a specific gravity of 4.2 to 4.4 and the hardness 2.3 to 3.5, where it is the common weight material for drilling fluid, which is almost same as powdered tamarinite. So next point is density also contribute to the stability of the borehole by increasing the pressure exerted by the wellbore fluid onto the surface of the formation downhole. Next, however, in drilling industry, bentonite is used for drilling fluid preparation. When mixing with water, bentonite clear from a viscous gel suspension which serve as a basis for drilling fluid. Okay. During borehole construction, drilling fluid flushes the borehole to clean out from cuttings, and it lubricate and keep the drill bit cool and for other specific purpose of drilling. And next is important properties of bentonite based drilling fluid is that it ensures the borehole wall stability by mudding. When the drilling fluid circulation is stopped, the clay suspension prevents cutting from subsidence. This will avoid or prevent from blocks in the borehole and as a result from any accidents. Specific features for features of bentonite clay as a natural material is that it is environmentally friendly. Um, Next is, other than that, the flow properties of the mud also depend on the depth of the hole and the annular viscosities. In the upper hole, water may be sufficient, but at greater depth, more viscous fluid may be required. And lastly, deep wells, directional wells, high penetration rates, high mud weight, and high temperature gradient create conditions requiring close attention to the flow properties, where the viscosity can be adjusted upwards with polymers or clay material, or it can be adjusted downwards with chemical, thinner, or water. So that's all from me. Thank you.